Hi everybody, it's Miss Mac with a quick little video to remind you about modeling with functions. Might be one of the harder things we've done, although you understand what the graphs kind of mean. Answering the questions can be a little bit tricky, so we want to talk about that. If you notice on this first page here, we have two different graphs. One's discrete, one's continuous, but if you notice, they all have the same kind of like corner points, if you want to call them that. So all of the points on the discrete are also on the continuous. The difference is the continuous graph is connected. So we want to talk about how the connected or not connected parts affect the meaning of the graph, as well as some of the characteristics. So the first example that we are going to look at is this one. And it is a discrete graph. And it says Julia works at Dairy Queen. She kept track of how many milkshakes were ordered during a 40-minute time period at work. The graph shows a relationship between the time and the number of shakes ordered. So if you notice, I don't know if I can move that out of the way. If you notice, across the bottom is time in minutes, and it said she recorded her data for a 40-minute time period. This point right here is the point 0, 0. It's one of the x-intercepts. It's also one of the minimums of the graph, along with this one. It's 40, 0. Those 2 points, if you remember, x is our time in minutes and y is our number of milkshakes ordered, both represent that at 0 minutes and also at 40 minutes, so the beginning and the end of the time period she was recording, nobody ordered milkshakes. This point right here, you'll notice, is the point 10, 2. 10, 2 means at 10 minutes, 2 different people ordered milkshakes. If I were to ask you what the maximum number of milkshakes ordered during that time is, you would tell me both of those points mean that because they are both at the same level. One of them is at 28 and the other one is at 38. And you would say to me, hey, Ms. Mack, at 20 minutes and 30 minutes, both 8 people came in and ordered milkshakes. Now, if I were to ask you, does it make sense for this graph to be connected, to be continuous? You need to think about the time, which is our x-axis, and you also need to think about the number of milkshakes because that's what we're representing here. Now, obviously, time can be represented in partial minutes. You can have so many minutes and so many seconds. So for that purpose, if I were to come over here and, put some point out in the middle and I asked you about a time, that would make sense. I could figure out what time that was or about what time that was. But if I think about my number of milkshakes ordered, nobody's going to come up and order 5.5 milkshakes, 7.5 milkshakes, 12 1/3 milkshakes. So because the number of milkshakes in this case, the range, the y values cannot be fractions or decimals, this graph has to be discrete. And so that's kind of an important thing to understand. The next example we're going to look at, which again is that same graph from the beginning, it's the continuous one. Notice that I put a different situation with this one. And it says Bill's mother sends him to the corner store for milk and tells him to be back in 40 minutes. The graph shows the relationship between his distance from home and time. So again, it's important to remember this is time in minutes, like it was last time, but this is distance from home in blocks. Now, before we do anything else, let's talk about this being connected or continuous. I know, like we said last time can be in partial minutes. The distance from home can also be in partial blocks because you don't just go from being 1 block away to 2 blocks away without passing all those little things in between. So this should be connected because my time and my distance, both my domain and range, can be partial numbers. They don't have to be whole numbers. So now let's just talk about what the graph represents. This right here is the point 0, 0. That means at 0 minutes before he started, he was 0 blocks from home. He was at home right here. Likewise, down here, this shows me at 40, 0. At 40 minutes, he was back home. He was 0 blocks from home, which means he was at home. So now as I look at this, I can kind of analyze what's going on. From here to here, I could say, oh, I would guess that maybe Bill is walking home. Okay, so this might be a walk home section. This little horizontal section, as soon as you see it being horizontal like that, you know he is not going any farther away from home. So this little section means maybe he stopped and he took a break. Maybe he saw an animal and he started and petted the cat. Maybe he saw a friend and talked for a few minutes. Then what happens is he decided, oh my gosh, I only have 40 minutes to get there. Maybe this section right here, which I meant to be purple, this, he decided, I better get there fast. So maybe he ran from here to here. So from 2 blocks to 8 blocks away from home, he ran. This little section in the middle, right here, probably is when he was in the store. He was looking for the milk. He was waiting in line to check out, maybe again, talking to a friend. And so this last section, he probably realized that, hey, right here is the point 38. That means at 30 minutes, Bill was still 8 blocks from home. And he thought, oh my gosh, I think my mom is going to have my head if I don't do something and get something done here. So he takes off, and this being really steep in the beginning means he was probably running right here. And then he got tired, or he realized he had a little bit more time. So he was slowing down as he got to home. And so that's kind of an explanation of what this graph represents. You need to make sure that you read the situation, look at the labels, and really analyze the points and analyze the sections of the graph if it's continuous to be able to answer questions completely, and make sure that you answer completely in sentences. Good luck with this. Bye-bye.